Okay, this is sequence and series day number 3, monotonic and bounded sequences. Let's talk. I don't know what this garbage is. Wacky wordies. Do that later on your own time. Crop circles. Hold assignment. Those are Doc Sauer's puzzles. BC multiple choice review. Hey, just so you're aware, on your test, you're going to have 2 BC questions. And they're manageable. They're both multiple choice, but they're worth 2 points. You got to show work for 1 point and get the right answer for the other point. So just so you know. Let's talk. Here's some sequence series review. I'm going to skip that. I want to go right to this. This is a whole lot of, to be honest, when I first looked at this slide, I said, what is this? Basically, all that this is saying is that if I take certain terms, right? Like, let's take term number 2 and term number 1. If I take term number 2 and subtract term number 1, how would this have to be related to 0 in order for it to be increasing? Which one would be larger? Term 2 would be larger, right? If term 2 is larger than term 1, then the sequence would be increasing, right? So if I go from 1 to 3, 3 minus 1 is 2, it's positive, therefore it's increasing. Okay, so I flip it around. What if this is negative, right? It's less than 0. Well, then it's decreasing. If it's always increasing or always decreasing, we call it monotonic. Monotonic increasing or monotonic decreasing. So all I'm going to do is take a term and subtract the term before it. Now, in order to check for boundedness, we have to check for 2 things. First of all, is it increasing or decreasing monotonically, right? And does it reach some kind of limit as n goes to infinity, which is what we just did yesterday. So let's take an example here, and let's look at it. Okay, here's my sequence. 2n minus 1 over 3n plus 2. First, I want to see, is it increasing or decreasing? So I'm going to take u of n plus 1 and subtract u of n. Now, how would I write that? Well, u of n is 2n minus 1 over 3n plus 2. But u of n plus 1 is 2 times the quantity n plus 1 minus 1 over 3 times the quantity n plus 1 plus 2. So what am I doing? I'm just plugging n plus 1 in for that n plus 1 term. Now, you might be able to anticipate right now, what are we going to have to do? Get a common denominator, and then show that this thing is either always greater than 0 or less than 0. So I'm going to pause the video. Let's do a little work on that. Those of you on the wide web, you can just see the work all of a sudden. We took and we distributed, and then we're going to find a common denominator. And we found that common denominator. Okay, up here, I got a FOIL. Somebody correct me if I FOIL this wrong. 6n squared plus 5n plus 2. Are we good? Oh, 7n, that's a 2. Yep, good. Thank you. That's why I keep you around. So I'm hoping that I get a 6n squared and a 7n, because then they'll go away and I'll just get a constant, right? So let's do that over here. Foiling, I get a 6n squared. Thank you. Oh, I get a 7n. And I get a minus 5. Okay. Look at that. And that's all over 3n plus 2, 3n plus 5. Okay, so we see that this will disappear, and then we'll get what in the numerator? Positive 7. So if n is greater than or equal to 1, which is how it works in sequences, we start at 1 and then we just increase, this will always be greater than 0. So this function, or this sequence, is always increasing. So far, are we good? Okay, if it's always increasing, well, where does it start? Well, let's plug in 1. Let's check when n equals 1. So u of 1, well, what would that equal? It'd be 2 times 1 minus 1 over 3 times 1 plus 2. So that's 2 times 1 minus 1 is just 1. 3 times 1 plus 2 is 5. So our starting point is 1/5. Does it increase or decrease from there? Increase. Let's find the limits as n goes to infinity of our function, or our, we could think of it as a function, but of our sequence. Where does that go? What does it approach? 2/3. So is this bounded? Yeah, it's bounded between those two values. Right? Does it increase the whole way? Yes. So that makes it bounded because it will go from the lower limit up to the upper limit, and it'll never go above that upper limit, right? So it's always increasing. So we can say now, we can say that this is monotonic increasing. That's due to step 1, which we proved in step 1. And it is bounded. Now, this is the important part. It is bounded because A of n is increasing, and the limit as n approaches infinity of A of n is equal to 2/3. Okay? So the limit exists, and it's always increasing. Could there be a limit? Would it be bounded if it was always decreasing? Potentially, yes, as long as it approaches some limit. But if it's not always increasing or not always decreasing, there could be some other stuff going on there, so the limit may not exist. Okay, so be careful for that. How do I know? Let's just be very clear about this. What if this came out to be that? It'd always be decreasing, right? Which is okay. We like that. We like always increasing or always decreasing. What we don't like is something like this, n minus 7, because sometimes that's negative, right? When n is equal to 1 up to 6, then it'd be decreasing, and then it'd be increasing after that. So we don't like when we get a variable in the numerator. We do like when it's a constant, because then we can predict would it always be increasing or decreasing.